Hello everyone. In this session, we will be doing something again which was related to the previous session or something new also. So let me start first with some special cases of equation of a circle or special situations we should discuss. The first situation is circle which touches both the axes. Now when I say circle touches both the axes, picture would be something like this. That circle can be in first quadrant or second or third or fourth. So I have written their corresponding centers also. First quadrant circles center I have shown as a comma e, and then second ones I have shown as second quadrant. I have shown as minus a comma e. Third is minus a comma minus a, and fourth one is a comma minus a, right? And radius in all the four cases is a, that you can see from the picture. Means whenever circle touches both the axes, radius if you are calling as a, then coordinates would be written in terms of a only, both the coordinates, x coordinate as well as y coordinate, depending on which quadrant it is. Accordingly, the signs would come plus or minus. Okay, so picture I hope is clear to you, and from here I will be writing the actual equation. Now center would be known to me, correct? And the center would be of the form either a or minus a for x coordinate, and same is for y coordinate also. So equation becomes x plus minus a whole square plus y plus minus a whole square equal to a square. Mind you, please, this equation I have written in the combined form for all four possibilities. Now, if your circle is in the first quadrant, then equation would be x minus a whole square plus y minus a whole square equal to a square. If your circle is in the third quadrant, suppose, third, so it would be x plus a whole square plus y plus a whole square equal to a square. If you are in second quadrant, then it would become x plus a whole square, y plus a, because x coordinate is minus a. So x plus a whole square plus y minus a whole square equal to a square. And the fourth quadrant would become, now it is clear to you, it would be x minus a whole square plus y plus a whole square equal to a square. So actually all four equations I have tried to write in one equation only. I hope you are clear with the picture and the equation. Okay, so what could be the next case? Let us take more specific case. That case is if circle touches the x-axis. If circle touches the x-axis, then picture would look something like this. Point on the y-axis would be shown as h comma 0, where the circle meets the x-axis, correct? And of course, center I will be showing as h comma k, where k stands for the radius. Now, picture is clear to you. Now, I will be writing equation of the circle in this case as, because y coordinate of the center is same as radius, I write equation as x minus h whole square plus y minus k whole square equal to k square. Now I am not simplifying that. I am leaving that to you because it is not required. In fact, if you ask me, I want that equation to be written in that form so that immediately you know what is center and what is the radius. Okay. And of course, as I said before, point where circle meets the x-axis will always be having y coordinate 0. Okay. Let us proceed further. What could be your further case? I'm sure now you all must be jumping. Third case is expected to be where circle meets, yes, the y-axis, and picture would be something like this. Now exactly on like previous case, now you know how to place the things. Point where circle meets the y-axis, means where touches the y-axis, will have x coordinate 0, and if that point I'm writing as 0 comma k, then you know that center's coordinates would be given as h comma k, correct? What is that h? That is center's distance from the y-axis. It's x coordinate, and hence it is nothing but the radius also. So we will be writing correspondingly equation as x minus h whole square plus y minus k whole square equal to h square. I hope things are now clear to you. And again, point where circle meets or touches the y-axis, its x coordinate will be kept as always 0. That you already know. Okay, now proceed from here and go to the next one. And the next one is position of a point with respect to a circle. This is different from whatever cases we have discussed by now. Here we are discussing position of a point with respect to a circle. Means whether that point is inside circle, outside circle, on the circle, etc. That is what I mean by position of a point with respect to a circle. Okay. Now proceed further as basic thing what you need is equation of the circle. So it is x square plus y square plus 2gx plus 2fy plus c equal to 0. One standard equation, general equation I have taken, which that expression of x square, y square, etc., the entire expression on the left hand side there, I'm naming as S, so that instead of saying that long expression all the time, we better call it as S equal to 0, right? So equation of the circle I'm taking as, say, S equal to 0. And of course, a point would be required. So that point I'm naming as, say, P x1 comma y1. Now these two things I'm expected to be given. And from here, what I do is we evaluate a quantity called S1. What type of quantity S1 is? In which we are evaluating x square plus y square plus 2gx plus 2fy plus c at x1 comma y1, means at that point P, right? So S1's expression becomes x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. The quantities would be given to you. X1, Y1 would be known to you. G, F, C, etc. would be known to you. So you can always keep ready that expression for S1. Now S1 decides everything. If S1 is greater than 0, then point P lies outside the circle. And if S1 is equal to 0, then point P lies on the circle. Correct? Why is it so? Because that means x1, y1 satisfies equation of the circle. If S1 is 0, that means point x1, y1 satisfies equation of the circle. Means point is on the circle. Correct? Now, if S1 is less than 0, then point P, now the third case left, is inside the circle. So, in the question, you would be given equation of the circle, you would be given point, and you have to do this exercise of evaluating S1. And then sign of S1 will decide whether outside or inside. And on this means it has to be equal to 0. Okay. Means picture would actually look, if you want to see the geometry, like figure form, then it would look something like this. Proceed from here further by taking one example on whatever we have discussed, right? And the example is one equation of the circle I'm taking, and that equation is x square plus y square plus 12x minus 3y minus 11 equal to 0. And that I'm calling as S. And now some points we will be taking to decide whether point is inside or outside. My first point is minus 5 comma 1. What I have to do? I have to evaluate S1. S1 means substitute in place of x minus 5 and in place of y substitute 1 and evaluate S1. That S1 turns out to be minus 48. That actual working I have not shown. You can try on your own and check. S1 is minus 48, which is negative. So where does point lie? Point lies inside the circle. Okay. Now let us take one more point, and the point is now 1 comma 2. Again do that similar exercise. In place of x, you substitute 1. In place of y, you substitute 2 and get S1. And that turned out to be 0, means point is on the circle. And one more only to satisfy ourselves. Now I am taking 1 point 3 comma 3. Again do that exercise and check where does that point lie, and we realize that in this case S1 turns out to be positive and hence point lies outside the circle. Now this was about how do we check whether point is inside or outside the circle. Okay, I hope you have understood by taking these examples. Proceed further from here and go to the last thing of this session, and that is that we have to find greatest distance or the least distance of a point from a given circle. How do we do that? So picture would be something like this. That center C, a circle I am shown there, a point A, x1 comma y1 I have shown, means that point is known to me. Circle is there with center C, radius R, etc. What we do is we draw a line through the center and point A. So PQ becomes the diameter, right? And by doing this, what we are doing, we are trying to see what would be the least distance and what would be the greatest distance. I claim by doing this, I will be getting AP as the minimum distance, which you can see in the picture. And that AP is actually AC minus R. Why I am giving you this expression? Because A would be known to you, C would be known to you. You can always get distance AC. R would be known to you. So AC minus R you can evaluate, and that will give you the least distance of the point from the circle. Okay. And now on the similar line, we will be having the greatest one also. What would be the greatest distance? It would be AQ. And will AQ not be AC plus R? AC again you can evaluate and R you can evaluate. So you know how to find greatest and least distance of the point from the circle. Now here I end my session. Next session when we meet, again something new you will be seeing. Till then, stay tuned. Thank you. Hope you have liked this video. To subscribe, please click on this side. Or if you want to place an order for the book, please click on this side. Thank you.